All right, today we are going to be learning how to solve rational equations. So equations are, have an equal sign. So what we're going to be doing is I'm going to take you through these steps that I have and on this equation. So you can see how they work, and then we'll do a few more examples to enjoy the greatness of the steps. All right, so the first thing that we want to do, or first thing that I do, and I'm just showing you what has worked for me in the past, is make all terms fractions. So what I mean by that is, if you're looking at this problem right here, this is the only fraction I see. So if I want to make all the terms fractions, I would put the x over 1, I would put the 14 over x, keep it there, and I would put the 5 over 1. Now this isn't as big of a deal as it is with monomials like this, but when you have a binomial on the top, it will make a difference. The second thing I like to do is keep change. So that's why I left this blank there. This minus sign here, I like to change that to a plus and change the sign of it above. Now again, it's something that I found works. It makes it so that we don't lose our negative signs as much. Next thing we want to do is find a common denominator. So we want to find a common denominator for all three, or every single term that's in this equation. So this one, and this one. So if you see here, we have a 1, an x, and a 1. A common denominator isn't really difficult to figure out. It would just be x. So then what I like to do is make every fraction have that common denominator. So right now, this is the only one that has the common denominator. These two don't. So what I need to do is I have to multiply, always multiply something by the top and the bottom. Basically, let's do this, you're unreducing it. So normally, you would want to get rid of a common factor on the top and the bottom. Now we're going to put one there so that it looks better for us. So those two both needed an x, so I can't just put an x on the bottom. I have to put one on the top and the bottom. So any factor that it's missing, that any term is missing, we just multiply the top and the bottom by. All right. When all denominators have the same denominator, we can eliminate it. So let's see what happens here. So I'm going to have x squared over x plus a negative 14 over x equals 5x over x. Well, we just made it so each one of these is exactly the same. When they're all exactly the same, this part of the equation is done. All I have to really worry about is the top. So there are, of course, other ways to go about doing this, but I really like this way. So this is the way I'm just going to go over. So all we're left with then is x squared minus 14 equals 5x. And then we just have to solve this. So this is a quadratic, so I have to move everything to one side. And solve. So just take a second and solve. I'm sure you could do it from there. All right, so what I got was x is 7 and x is negative 2 here as my solutions. Now the last thing that you have to do is check for extraneous solutions. And that means do any of the solutions make the fraction undefined. And I'm truly talking about the original fraction, but since they all have the same denominator, technically it's the common denominator. So what you can do is take whatever the common denominator is and make sure that it's never equal to 0. So you take each one of the values. So I'll take 7, see if that's equal to 0, and it's not, so we're good. That's the check. They can't be equal to 0, so we're good. So plug negative 2 in, make sure that's not equal to 0. I know this seems kind of stupid, but and that's a check. You can check in the normal way and put it in and make sure it works for both sides of the equation. However, this is an important part. So I don't have to reject any of these. My two values, so x could be 7 and negative 2. Both of those work. So that is in essence how to solve equations that are fractions. So let's just do a bit more complex problems so you can see the problems that may come up while we do them. So my first step, make everything a fraction. Okay, so do that. Second thing is keep, change, change. So I'm going to change this to a positive and make the 2 negative. Again, not necessary. However, you're going to lose your signs if you don't take some precautions for that negative sign. Now we have to find our common denominator. So this is the one that shows up and we try to trick you every time. Remember, when you're changing denominators, you can only multiply. So I must multiply factors to make one another. So I cannot multiply x by anything to make it x plus 1. I would have to add. And you can't add something to the top and the bottom of a fraction. That just doesn't even make sense. These two do not have any common factors. So in essence, let's think about this. If I do 1 over 10 plus 1 over 5, okay, these are common factors. This one has a common factor. So example, I can break this up and I go, this is 5 times 2. So these both have a 5. So the only thing I really have to do is multiply this by 2, and I would get these able to be added. Or I would get a common denominator for these. But if I look at 1 over 2 plus 1 over 3, they don't have anything in common. I can't just add 1 to the 2 to make it work, or subtract 1 to the 3. It just doesn't make sense. And if you were to do this problem that we have right here, it's in essence the same thing. If this was x, this one would be x plus 1. 2 and 2 plus 1 is 3. There is nothing in common. Nothing. All right? I'm sorry if I maybe confused you a little, but that's a very deep concept that you have to understand. All right, I can't erase that, so I have to just keep going. All right, so the common denominator is we would just have to multiply together. Just like this one, I would have to multiply this one by 2 and this one by 3. So I would have to multiply it by the whole other one. So the common denominator here is x and x plus 1. Just multiply them together, there's nothing else you can do. So to put these together, to put what's, to get them to have their common denominator, this one needs the x plus 1, this one needs both, and this one needs just the x. So I have to get all the denominators to have an x and an x plus 1. So this one had an x, so I have to put the x plus 1 on, and so on. So what happens here, when I do this, is I am left with 3 times x plus 1 over negative 2x times x plus 1 and negative 2x squared over x. So all the denominators are the same, so I can eliminate them. So it's and this is the equation that you need to solve. So I'd like you to take a minute and solve that equation. This is not a lesson on solving quadratics. So this isn't even a quadratic. This turns into a nice linear, so it should be all set. So take a second and solve it. Okay, so I got x equals negative 3 for my solution. Final thing that I have to do is I do have to check the denominator. So you can just take the common denominator, that one, and plug in the negative 3 and make sure that it's not 0. And I just have to make sure it's not equal to 0, and in this case it is not. It is what? Negative 6. So 6 is not equal to 0. So 3 is a perfect answer, or negative 3, excuse me, is a perfect answer. All right, let's try the next one. Right, so here we have an interesting one. We've got lots of stuff happening here that we have to account for. So when we're doing these, everything's already a fraction. We're good. There's no subtraction, so again, we're all set with that. So what we need to do is find the common denominator. Now this looks crazy, like everything's different. It doesn't seem anything's right. So one of the things that you want to remember to do when you're finding a common denominator is factor the denominators. So you can see if they denom. So you can see if they have anything in common already. So this is already factored. This one is x minus 3 and x plus 2. And this one is already factored. But we are going to switch that one around because hopefully you see these two are common here. These two are the same. So they have a common factor. And this one is very, very close to this one. So we are going to have to switch this around. I want to make this one, excuse me, x minus 3. So to do that, hopefully you remember you can use, it's called the, we'll call it a -1 trick, where if I multiply the top and the bottom, so remember we don't care if we multiply the top and the bottom of the fraction by the same thing. It doesn't change it, it just unreduces it. So when that happens, this happens. Plus a -1 goes on the top, but then each one of these gets changed. So 3 times -1 is a -3, and x times -1 is an x. So now this and this are the same. So now my common denominator, you can see, all we have to have is all of them have to have the same factor. So it's x minus 3, x plus 2. If I multiply them by this, so if I multiply this one by x plus 2, its denominator is going to be the same as this one. If I multiply this one by x minus 3, its denominator is going to be the same as all of them. So now the denominators are the same. I can eliminate, and that's what I was going for. Whoa, something just happened, sorry. 2x times x minus 3 equals, now just eliminate it and rewrite it here. All right, so take a second, solve this equation, and we'll come back. All right, so my answers I got were x is equal to -1/2 and x is equal to 3. My work is here if you want to check it out. So the last thing that I have to do is check for the denominator here. So the denominator was x minus 3, x plus 2. And I want to plug in each one of these. Now I'm looking at this one and this one, and I'm saying, oh yeah, that's not going to work. So if I plug 3 minus 3 in here, remember the denominator can't equal to 0, and x plus 2, or sorry, 3 plus 2. So when I do this, 3 minus 3 is 0, so this becomes 0 times 5, which is equal to 0. So what that means is this 3 must be rejected. So we do a reject here. And then you also must check the -1/2. However, when you do check it, it's pretty blatantly obvious that it's not going to be 0, but just put it in your calculator, make sure. So that's not equal to 0. So our only solution here is x equals -1/2. Okay, the final one, pretty a bit easier than the rest, but it's worth a look at so you don't get confused. When you do have a fractions equal to a fraction, remember that is a proportion, and proportions are very easily solved by cross multiplying. So I just wanted to throw this in here to remind you that even if the question is oh, sorry, I think I just muted it. It worked out all nice. All right, you have a fantastic day.